Now we're going to work with MODIS data, plot some NDVI time series. The data set we're going to use is this one. This is vegetation index collection, which has both NDVI and EVI bands. And we have this collection from 2000 onwards. Every 16 days, you get a composite image of the NDVI. Very widely used data set for vegetation monitoring. So we'll use this and let's see, we want to know the vegetation dynamics in a region. How does the vegetation change over time? And we want to see if there's a year-on-year change. This collection also has to be pre-processed. You can see there's a scale value given here. So the values of the NDVI are between -1 and +1, but the pixel values are multiplied by 10,000 to scale them to get the actual NDVI values. We also have cloud here in the data. So we have to mask out clouds, otherwise we'll get outliers. So let's do the pre-processing. Let's do this first. Okay. So we have the MODIS collection. Let's say we want to plot this time series from 2019 to 2022. We have the MODIS data filtered for this date range. We are scaling the pixel values. So this is the same function we used in our first script. So take this image, divide by 10,000, or you can just do multiply here as well. Multiply by 0.0001, right? Same thing. And copy the properties. And we take the filter collection, map that, and select the NDVI band. And we just want to plot that. So let me plot that. And you can see we have the NDVI time series going from 2019 to 2023. So long-term time series. This data, this collection works, but we have not done any cloud masking. And if you don't do cloud masking on any optical data, you'll get outliers. So look at this time series. We have this kind of outliers. You can see this data. In the next 16 days, NDVI drops to all the way down. And again, 16 days back, it comes up, right? This is likely not the case here, right? It's probably just fell like this. This is a cloud. There's a cloud here. And that means clouds will lower your NDVI. So you will get this kind of outliers. So again, you don't want this, you want to mask this pixel values. So let's apply a cloud masking function. We have to use the QA band here. There is a QA band called summary QA that comes with it. There are 4 values here. So we have good data, marginal data, snow and ice, and cloudy. So we want to mask all pixels, which are both snow and cloud, because again, they are not representing the vegetation condition. So I'm going to just use a cloud masking function and apply that here. So I have the cloud masking function. This will say, give me all the values with less than or equal to 1 for the summary QA band. And this is the summary QA band 0 and 1. You'll select those pixel values. And we're going to map that again on this one. So we take our collection, map this function. And now when I run this, you'll see the outliers are gone. You can see I don't have outliers anymore. There's one more parameter that is useful. That is when I visualize this data, you can see there's a parameter called interpolate nulls set to true. Let me set to false and show you what happens. This is how my data looks. Right? You can see there are gaps because those gaps have been masked. If I don't mask it, let me just comment out this function. I'll get continuous data, but with outliers. You can see this is my outlier. After cloud masking, it becomes like this. All those anomalous values where there was cloud got removed, and I have this. Right? So this is the correct representation of NDVI. But if there's a gap here, so what happens between these 2 dates, we don't know, right? Because we have no observations. So we can linearly interpolate and say the value must be in between here. So there's this parameter interpolate nulls, which will, if you set to true, will just fill those gaps for you with a linear interpolation. You may or may not want that, right? So it depends on your use case. If you don't want to keep this, set it to false. So you can actually see the gaps in your data. But if you don't want to fill this up, you can see this. Okay. So now we have a nice NDVI time series. And if you look at this time series, it's a 4-year time series. You can kind of see the overall year trend. But again, do you see something odd that happened between different years? Yeah, 4 years is the NDVI pattern changing? Is the growth season time shifting? We don't really know because we want to compare them year to year. We don't want to just plot a single time series. So if you want to compare data year to year, we have another function here, which we're going to learn, DOI series. DOI series by year. This will plot the values for each year in your data from day 0 to day 366, depending on how many days are there, right? And it'll say at day 1 of the year, this was the value across all the different years. So if you have 4 years, you'll get 4 values for a y-axis. And that will allow us to compare this data year over year. So let's try to plot this. We have this processed collection, which we need to plot. So let's just do image DOI series by year. This is our collection, the band name, NDVI. We have 2 bands, so we can do this region, geometry, region, reducer, reducer mean. We are plotting this DOI time series, that means there'll be one value plotted for each day. There is one more parameter here called same day reducer. What if there are multiple values for the same day? You have 2 images that were collected on the same day. What value should be plotted? So this also can be specified as mean if you want. In our modest case, we don't have multiple values. But if you have Sentinel-2 or other data where there are multiple observations, you have to specify this as well. Scale, modest scale is 250 meters. This one is 250 meter data. Start day, end day, we'll just do the full year. Okay, so now we'll plot this. And you can now see my chart goes from day 0 to day 365. And we have the NDVI values from that collection plotted on top of each other. So you can see at day 145 in 2019, this was the value. In 2021, this was the value. So now you can see the yearly changes in NDVI pattern. And if there is a shift in season or if there is a change, you will be able to see that. Very useful to compare kind of yearly change in weather patterns or climate patterns. You can see this NDVI typically follows this kind of curve, right? You have seasonal pattern. And because we have masked few data, and you can see this one is a straight line between this because we have linearly interpolated. But you know it's not linear, right? There is a kind of gradual growth. The right way, if you want to do this, you can do, we have function that will actually fit the function to the image and generate all those points. We have a time series processing code available. But if you just want to plot that, you say, I don't want to do any pre-processing, I just want to plot that. We have this function here in your options. So let me just show you the options here. Called curve type function. So the default curve type is your linear curve. Now, if I just change the curve type to be function, it'll basically fit polynomial to my data and give you a smooth data. So you can see my data has been smoothed out and I get a nice curve of NDVI. This is a kind of gives you much better visualization. And this kind of gives a more natural interpretation to your data. Okay. So you can use this curve type function for that. In Earth Engine, whenever you need some colors, you can use your regular color names, red, blue, yellow, whatever. But if you want good colors, your chart to look good, I recommend using this website called Color Brewer. This is a website which gives you color advice. So I use it all the time for QGIS, Earth Engine, Python. Whenever I need a color palette or a color, I use this. And the way to use this is you can select a color palette that you like. You can say how many classes you want, and it'll give you this color codes. And you can use this color codes in your Earth Engine. So instead of using red or blue, you can just say, I want this color code. And all these color codes will look good. You can also export this as a list. So if you want a palette for a visualization, you can just copy this and use this. Okay, so use this, your maps and your visualizations will be much better rather than you trying to come up with the colors on your own.